Shall I start, sir?
Yeah, you can start, ma.
Good evening to one and all present here. I am here to volunteer for today's session. Now, I would like to extend my first and foremost gratitude to our Honorable Chairman, Sir, Dr. B. Babu Manoharan, our Managing Directors, Mrs. Jessie Priya Ma'am and Mr. Shashi Sekhar, Sir, and our beloved Principal, Dr. P. Ravichandran, Sir, for giving this opportunity to conduct this webinar. And it's my pleasure to welcome Mr. Kamalesh, Sir, the wonderful speaker of today's session, who has more than 3 years' experience as a data scientist. And I thank you, sir, for making your presence here. And I would also like to extend my gratitude to our head of department, Dr. C. Gnana Kausalya ma'am and Dr. G. Rohini ma'am for their ceaseless support. Before we start the session, I would like to tell a few instructions to be followed by the participants. Kindly post your queries and questions in the chat box and they will be discussed at the speaker at the end of the session. And the attendance link will be posted at the end of the session. Now I invite our speaker to kindly start the session.
Yeah, thank you. So, yeah, welcome to day 5 of Yeah, thank you. So, welcome to day 5, convolution neural network, how we can use and what is the use of convolution neural network algorithm. Let me see. Okay. So, in this session, I'm going to teach you how the convolution neural network algorithm is working. Okay. And before that, my voice is clear. Just send a message in our chat box. Anything echo is there or my voice is clear? Yes, okay, fine. So, convolution neural network algorithm is one of the most important algorithm for training an image type of data set. Okay, so till now, from day 1 to day 4, we seen how we can train number, how we can train categorical value of data sets, and how we can train even text data set also. Okay, so we have one like now today's we are using a image type of data set and we are going to train the algorithm. Okay, so before entering into this convolution neural network algorithm, this webinar, this workshop will be have like two part. The first part is basics of image and then basic of convolution neural network algorithm, just introduction of convolution neural network algorithm, and after that will be move on to the technical part. Okay, so we'll be have totally two part. One is basic of image and convolution neural network algorithm. After that we'll enter into the this part. Okay, the part is technical. So for this data for this today's class, we don't need any data set and all. Data sets and all inbuilt only. Okay, we are going to take the data from the keras itself. Okay, so now I will tell you some basics of image and then convolution neural network algorithm, then we'll enter into the technical part. Okay, so I hope this is the last day and this is a more interesting one. Why? Because most of the persons are looking for this only, how we can train the image type of data set, how we can detect the objects. Okay, so this will be useful for you even though for your future purpose also. Okay, so just listen it and then work on it. If you are free, you can use with your laptop. Here we don't need to import the data set and all. We already have a data set. Just you need a internet connection and Google Colab. That's enough. Okay. So if you're free, you can work on it. Let me start the session. So first of all, I need to tell you some basic information of image. Okay. So I'm using paint. So generally, you guys will be know like if you take one image, the image will be consist of some pixel values, pixels, right? So this pixel, the whole pixel will be called as a resolution. For example, you can take it as a 64 into 64 megapixel. Okay, so like this you can take the 64 into 64 megapixel means it's a resolution of your image. So generally, if you are take your own image in any image, okay, in your mobile phone or in website, it should be in colored image, right? So normally, if you have a color image means you will be have a resolution plus plus layers. Okay, if it is a color image, they will have a three layers. One is red, green and blue. Okay, so generally 64 into 64 megapixel will be have three layers. Okay, if it is a color image means three layers means like this. Okay, so three layers will be there. So within red have 64 into 64 megapixel value, green have 64 into 64 megapixel value, and blue will be have 64 into 64 megapixel value. Suppose if you are taking a grayscale value is nothing but black and white image. Okay, so if you take a grayscale value, it should be in the form of only one layer only. So it will be called as only the resolution 64 into 64. But if you take a color image means we need each and every pixel have some colors, right? So that's why we are using red and green blue. So normally you guys will be know about this RGB and all. Okay, as an engineering student or as a general, it's a general one. Okay, general thing. So that is the combination. So each and every pixel will be have some values. Okay, from 0 to 255. Okay, so this is the color range. Okay, from 0 to 255. So generally what we are telling like we will be have a pixel values. Generally you will be hear about the word pixel, but what is that pixel means? It's just a integer. Okay, it's just a integer from 0 to 255. So here I told you we are having totally three layers. So three layer will be the combination of three layer integer will be called as a one color. Okay, so that is the uses of this one. So color will be start with white to black or black and white like that. Okay, so this is the simple image properties. Okay, so generally you guys will be know what is the image and color image and all. So generally if you take on color image means you will be have a three layers and resolution. Here I am taking just example of 64 into 64 megapixel, but we will be have a some resolution also, and then we will have this color range. Okay, so I hope this simple example will be understand. It's a easy one. Okay, so if you understand this part only, you will be comes to know how the CNN algorithm is working. Okay, so I'm going to now PPT. So here you can see this is the example I am taking here. The PPT consists of one image, cola image. Yeah, it's a cola. Okay, so most of the guys will be understand after seeing the image based upon how you will be comes to know it's a cola based upon some features. So what are those features? This one, nose and ears and hands and legs. Okay, so based on this property we will comes to know, yeah, it's a cola, right? So like same thing only convolution neural network algorithm also train. Okay, so whenever you are giving any image to the convolution neural network algorithm, first it will be take a part by part like this: nose, ears, hands, legs. Then after that it will be combine all the part into a single. Then finally I will be get an answer cola. Okay, so this is the way it will be trained. In this PPT I am going to show you two type of example. Okay, for our understanding purpose, I am going to use two type of example. Okay, one is this cola image, another one is number digit. Okay, like 1 to 9 number digits I am using. So for our understanding only, I am taking this two example. Okay, so for suppose we see in about for cola, it's working like this. Suppose if it is a number means how it's working. Like here you can see this is the working procedure of if you need to recognize your number digit means like this only. So first it will be take some pixel values here, and then combination of this pixel value I'm getting the circular pattern. Okay, I'm getting the circular pattern. Then combination of this two I'm getting the vertical line. Then combination of this I'm getting a diagonal line. So if you are having, whenever you are giving an any input number digits, okay, if you are having this loopy circle pattern and vertical line pattern and diagonal pattern, if you are getting like this three pattern means definitely you want to give as an output it's an ion. I am training like this as a neural network algorithm. Okay, so that is the use of this number digit. Okay, so I hope this will understand you guys how the convolution neural network is working. Okay, so if you take a convolution neural network algorithm, the convolution neurons is not a it's a important only. Okay, the combination of convolution neurons will be we will be use some other neurons also. Okay, not only particularly convolution neurons. Okay, we will use some other neurons also. That also I will tell you. Okay, so this is the use of convolution neuron. Okay, the next one here you can see, suppose if I give a input, new input, this image, this is my new input. So how neurons convolution will be uh, how the convolution neural network will be work. So based on your this, okay, so loopy pattern and then vertical line filter and then diagonal line filter. So the combination of this, it will be give the output result. So here I am taking like you can take it as a this one as a new example. I don't know. Okay, I don't know whether it's a 9 or whether it's a 8 or whether it's a 7. This is any input image. Okay, so I'm going to multiply this input image with my loopy pattern. So what are the patterns are available for 9? Loopy filter pattern, okay, and then vertical line filter pattern and then diagonal line filter pattern. Okay, so whenever I am get a input from the new input, okay, so the input image will be multiply with this all the pattern. Okay, see here I'm just showing only one pattern. Okay, so here I'm multiplying, adding all and dividing, and then I'm getting an answer. Then I'm creating a new matrix, then I am giving. So like this I will be multiply for all the from here to here. Okay, line by line. So 2 comma 2 matrix like that. I'm sorry, here I am taking 3 comma 3 matrix. Okay, 3 comma 3 matrix. So this is for example loopy pattern I am doing. Then I am getting on future map. Like same thing I will be do for any kind of input image. Okay, I don't know whether it's 9 or 6 or 8, but I will apply same. For example, 9 will be have a loopy pattern, and for 6 also will be have a loopy pattern. Okay, so loopy pattern will be changed. Okay, even if you take a 8 means the loopy pattern of 8 will be changed. If you take a double digit 96 means the loopy pattern will be changed. Okay, so here I can see it's changing our output. Okay, so like this I will check my input data by some important patterns. Okay, so that is the use of this image. So suppose for example here I am taking cola, so I need to detect whether where is the cola I in the image. So here I will use my cola image I pattern. Okay, then if I multiply my new input image means I will be get a output where is my cola image. Exactly, yes, here it is. Okay, like same thing I can multiply for another one cola image also, so I will be get a loop image like this. So for example here I can say I'm having a totally 3 cola image. So I'm getting an output result like this. So this is the way you can detect your, based on the patterns, you can detect your particular field in your image. Okay, so here it's 9. So I already told you if for 9 we are having a loopy pattern, vertical pattern, and another one. Like, so we are having 3 filters. So I am applying all the 3 filters. I am getting a 3 future maps. Okay, so like this we need to do for each and every image to find an output result. Okay, so for example if I have an image of cola means I will be apply all the loopy pattern of eyes, nose, ears, and I will be get an output. This output I will be concatenate, and then I will be get a one filter head. Then after that I need to find an output result. So like this I need to do. Okay, so this is for head and body, and after head and body we need to train the our dense layer. Okay, so dense layer we already know dense layer, right? So dense layer previously we used in simple artificial neural network algorithm. So applying using dense layer I will train the algorithm and then I will predict an output result. Okay, so this is the way you can find your input futures and then combine your input future and then predict your output result. But here one mistake is there. Okay, so what is that mistake is, so if I take all the input data from eyes, nose, ears, hands and legs, my each and every data if I combine as a one single input means single output means, so definitely I will be have a large set of values, right? So I will be have a large set of values. So when I do for only one image means I will be get a some large set of value. So if I do this same steps for 15,000 image or 16,000 image or even 1 billion image means definitely my output will be a vast. Okay, so we can't, we need to create a billion and trillion number of neurons to train the model and to predict an output result. Okay, so this is one of the drawback with the convolutional neural network. Okay, so if you want to reduce this complexity, that's why we are introducing the another one method. The method is called as a this one. Okay, pooling method. Okay, so pooling method is one of the important method in convolutional neural network algorithm. What is the use of pooling method means? Pooling method will be totally have two type. One is average pooling. Okay, average pooling. Another one is maximum pooling. In name itself we will comes to know average is nothing but whenever I am having any filter, within this filter I will take some average value. For example, if I give the pooling method 2 into 2 2 comma 2 matrix means here 2 comma 2 matrix, first 2 comma 2 matrix, if I apply maximum pooling method means what is the maximum value here? 8. So 8 will be a output. Then next 2 comma 2 matrix, here what is the maximum value? 9. Then 9. Then next 3 3. Okay, so like this I can get my result. Okay, so like this I can get my result by applying the pooling method. So when I apply this pooling method or average maximum pooling method or average pooling method means definitely I can reduce my data. I can reduce my future data, future pattern into a smaller. Okay, so that is the use of pooling method. Okay, so here you can see I am taking the loopy pattern and I am taking one general image. I am multiplying with the loopy pattern. After I am multiplying with loopy pattern, I am getting this output result. Then this output result in the form of both positive and negative value. So I am going to apply the Relu activation function. So what is the use of Relu activation function? It will be tries to try to change our input data into the non-linearity way. So here, after that, I am getting this output result like this. Okay. So here you can see you can analyze what is the working of Relu activation function. So I already told you, if it is a negative value, it's the range of Relu is nothing but 0, x. Okay, so if it is a negative value, automatically it will be taken as a 0. If it is a positive value, it will be move towards the next neurons. So that's already I told you, right? So here you can see my input here negative, negative, negative. So here are some negatives are there. Okay, so what the Relu is doing, the negative values available, where are the negative values automatically turned to 0. So this is the working procedure of Relu. Okay, here we can see detail. Okay, but here you can see 0 point level, 0 0.33 or 1. I'm getting here positive value, but it's transferred directly. Okay, so that is the use of Relu activation function. So after applying the Relu activation function, I am passing this data to the pooling method. So pooling method is maximum pooling method. Now only I told you what is the use of maximum pooling method. So we can find the like we can apply any 2 into 2 matrix or 3 into 3 matrix, and then we will check what are the maximum value available in our this filter. Okay, so that is the use of maximum pooling. So after I am applying the maximum pooling, here you can see I am getting an output result like this. So this is the uses of our whole convolutional neural network algorithm. Okay, so like this only we have to create. Suppose if I need to create like this, I need totally 2 neurons. Okay, one is convolution neurons with a combination of Relu activation function, and another one is maximum pooling neurons. That is, I need to create a layer, convolution layer, and then maximum pooling layer. Then after that, I need to add a dense layer. Then after that, output layer. Okay, I will show you the architecture. Okay, so this is what I need to tell you about how the convolution neural network is working in our things. Okay, so I'm moving on to the next slide. So suppose if you are applying the average pooling, the working of average pooling is this one. So that is we need to add all the value and find the optimal value, and then need to pass the things. This is the average pooling. Okay, so this is the architecture today we are going to do. Okay, so I will download the data set from the Keras. Okay, and downloading the data set from the Keras. Then after this, I'm going to create my architecture, that is first convolution layer, and then next I'm applying the pooling layer. This convolution layer will be have more features like I know, CEOs, etc. Then I am passing into the pooling layer. So the pooling layer will be take some important data, then it will be give it to the next convolution layer. Again, the next convolution layer work on with head and body, then it will be moved on to the pooling layer. Okay, so that is the use of this is method. Okay, so then after that I'm getting my result will be in the form of matrix. So I'm going to flatten my result. After flattening the result, I'm passing into the my dense layers. So dense layer will be trained and find the output result. So that is the use of this. So now I will enter into the technical part. Okay, I hope you guys will be understand about how the CNN is working. Okay, so now I'm just to move on to the technical part. Okay, so here first of all you need to know the data set. Yes. So whenever you need to develop any model or any machine learning model or deep learning model, you have to understand how your data, that is you need to analyze your data. Okay, so here I'm already have opened our dataset information. So this is CIFAR10 dataset. Okay, so here in this, actually this is the already like already generally they will take some images of aeroplane, automobile, bird and cat, deer. Okay, so it's an open source dataset only. So the dataset name is CIFAR10 dataset. What is the thing is they taken different type of class like aeroplane, automobile and bird, cat, deer, dog, frog, horse, ship and truck. Okay, so they have a different type of images. Okay, each image will be have like 6,000 images. That is, each class will be have 6,000 images nearly. So what is the thing is we are taking the images of 32 into 32 color image in 10 classes. 10 classes means this one. Okay, so totally we are having 16,000 image. All the 16,000 will be, all the 16,000 image will be converted into a 32 into 32 megapixel. Okay, so converter means here we are not cropping the image, we are compressing the image, that is transforming our original image into a 32 into 32 megapixel. We are not cropping the image. Okay, so that one it's important. So here we have that 16,000 image, each image have 10 classes with 6,000 images per classes. Okay, each and every, that is aeroplane means we will be have a 6,000 image, automobile means we will be have a 6,000 image. There are 15,000 image will be a training image and 10,000 image will be a testing image. Okay, so 15,000 image will be a training image and 10,000 image will be a testing image. So now we are going to use this dataset only and we are going to predict our output result. Okay, so the dataset divided into 5 training batches and then each one 10,000 images. The batch consists of, so this one we don't need, but this is the image detailed information. Okay, so if you need to download, you can download for Python, MATLAB and binary versions also. Okay, so if you need this link, I will share it to you in our chat box. You can check it out. Okay, so using this image only I'm going to do. So first of all, I'm going to import some basic packages from Keras and then model. Yeah, we need to connect, right? Just connect it. So after this workshop, I will share the code link, that is code day code. Okay, from starting first day to day 5. I will share the code link in our Zoom chat box link. Okay, so for you can share it to your friends also who are watching. If they need this code file, I will share it to you. Okay, so you can pass to your friends. Here I am using from Keras models and then importing the sequential. Yes, same sequential what we used in previous, and then from Keras I am going to use layer. Yes, layer I am going to import one most important layer is, we will check according to our architecture. Okay, so here you can see this is our architecture, right? So first I need a convolution layer, right? So I will import the convolution layer. Here I'm using image, so convolution 2D is enough. Then after that, what is the layer I need? I think we need a pooling layer. Yes, so here I'm taking a maximum pooling 2D. Then we need to use any other layer pooling, flatten function we need, right? Flatten. Then after that, yes, dense layer, then output layer. So I'm going to import dense layer, and then finally one layer we need to use, that is the dropout layer. Okay, so dropout layer, yesterday also we used why we are using this dropout layer means we need to try to fit the model as a optimal fit, that is robust fit. Okay, so that's why we are using dropout. So whenever my neurons and some unwanted neurons will be there, the data will be vanished. Okay, so to now I imported everything. Then I need some packages like from Keras. Okay, I need to convert my data output data into a categorical one. So I'm going to use this two categorical. Okay, then I'm importing basic packages. Import numpy as np, then import for displaying the pictures. I'm going to use matplotlib. You can use even OpenCV also, but using matplotlib also we can plot the graph. Sorry, plot the image. So I'm going to import those packages. Then after importing the packages, I need to I need to import some basic image data set. Okay, so till now we are not importing, right? So I'm going to use from keras dot datasets, then import what is the dataset name, CIFAR10. Okay, so here CIFAR10, even 100 also available, but I am importing 10. Okay, so now I imported, but as we discussed on past 3 days, we need to save our data into 4 variable x train, y train, x test, y test. Yes. So in x train and x test, we will be have an image. In y train and y test, we will be have an output of the image. So what is the output here? So output here is nothing but we will be have a array value of 0, 1, 2, 3, 4. 5, 6, 7, 8, 9. Okay, will we have an array value. So array value 0 means aeroplane, 1 means automobile, 2 means bird, like that. Okay, here x train, comma, y train. This is 1, and then x test and y test. Okay, here I'm going to call the CIFAR10 dot, I need to load the data. Then after loading the data, I need to save it in this train and test. Okay, so here it's downloading from online. Don't worry, if it is a 16,000 image also, it will be download as soon as possible. Why it's downloading as soon as possible means I will show the one output of the image, means then you will be comes to know why it's big, this much speed. Okay, so here now I downloaded everything. In train I will have a image, in y train will be have a output. Okay, so now I'm going to check the shape of the train. Okay, so if I check the shape of the train, I will be get an output in the form of like numpy. Okay, so that's why we are getting a 16,000 image within 6 seconds we are downloaded. Why we are downloaded means all the images will be in the form of numpy and nd array. Numpy and nd array means it's an array value. Yes, you are thinking that it's right. It's in the form of array value. As I said before in the starting of the class, each and every image will be have some pixel value, right? So those pixel value is nothing but we are take it as an array value. Okay, so the combination of those array value will be get a image. So how I will tell you now. Now I am going to show you the shape of the image, shape of the image. Here you can see 15,000 image I am having 32 megapixel and then 3. Okay, 3 layers, 32 megapixel of each image with 3 layers. Suppose, for example, I am going to print one image, one first in 50,000 image. I am going to print the first image. Okay, I am going to print the first image in my train data. So what is the output? The output is nothing but only pixel values of my 3 layers. See here, 1, 2 and 3. 3 layers we are having. Each layer output only we are getting. Okay, so here you can see we are dot dot dot, that is we are having a lot but it's not displaying a full output. Okay, so X train we are having a pixel value, this one. What is the combination of this all the pixel value? If I see the combination of all the pixel value by plotting this matplotlib, means you will be get a image. Okay, so here this is the output. Okay, now I am going to plot the image by using matplotlib. Then you will be comes to know why we are getting a output like this. Okay, so now okay, what is the image I taken previously? Previously I taken first image, right? Yes, so I'm displaying this first image to you now. So this pixel value consists of one image. I'm going to use plt matplotlib, then using imso function. Function. So if you want to read the image, you need to use im read. Okay, here I am using imso, and then I'm going to print the xtrain first image. Okay, so previously I displayed you first image only, but I am getting an pixel values. Now see here, even I told you pixel value will be consist of 0 to 55. Here also you can see it will be, your output will be not more than 255. Okay, within 55, 255 only. Here I am displaying the first image. If I run this, I am getting an output like this. Okay. Yes, what you are thinking, that's right only. It seems like a truck. Okay, it seems like a truck image. Yeah, so truck means according to my Y train, what is the array value I want to save in Y train first index value? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, if I print the Y trained first value, I need to get an output result as a 9. Okay, so we'll check whether it's displaying correctly or not. White line 9, 3. Okay, so 3 I am getting, sorry, first image only, right? White line first image. Here I am need to use 1. So now I am getting here 9. Okay, so yes, what we have predicted, it's correct only. It's a truck image. See guys, it's a truck image only, but compressed with 32 into 32 megapixel. Okay, so now you can get my point how the image is working during a training a mission, deep learning or machine learning algorithm. Okay, so everything using by this pixel values only. Okay, so now everything is fine. We got a output what we looking for, what we looked, and then we got output same. Now what I am doing here means just taking an okay, so everything is fine. Now I'm going to use convert my data. Okay, so here we can see I'm getting an array value as a 9. I'm converting this array value into an categorical value. Okay, categorical value is nothing but one hot categorical. One hot categorical is how? you will get on doubt. So I will show you the output, then you will be comes to know. Here already I imported my two categorical function. So I was using that two categorical only and go to convert my array, all the array value into one hot key value. Okay. So how I will tell you now. Here I am creating a new variable white rain one hot. Okay. Like for this in white test also I am having same output only as a that. So I am going to use here white test. Okay, white rain and white test. Now I am going to convert my data into a two categorical. Okay, so I am calling the function two categorical, and here I am using white rain data and then two categorical white test. Okay, white rain and white test. So now I am converting and I will show you after converting I will show you for the same first output what we are having in white rain. Okay, so I am converting. Now I am displaying the first image output. So this is the difference. Before we are getting an array value, original array value as a 9, but instead of this, I am using this two categorical function. Then I am converting my all the output data into like this. So whenever I am getting an value, those value will be changed as a 1. Then apart from this, everything is 0. That is called one hotkey encode. Okay. So why I am converting like this? Means we are having totally 9 classification from 0 to 9 we are having 10 classifications are available. So whenever I am training the output and predict an output result, I will use 10 output neurons. Okay, previously we used only one output neurons to predict an output for classifying binary type of classification, but here we are having a 10 classification, so we need to use 10 output neurons. So within the 10 output neurons, in which neurons I am getting a highest score value, that is the probability of convolutional network like that. Okay, so that's why we are using this 10 this like this. Okay, so now you will be comes to know what is the use of two categorical. Then after this converting of two categorical function, I am going to show you how we can normalize your pixel values. Okay, how we can normalize your pixel values. So we need to normalize our pixel values of data also. Okay, why? Because here we are having a data type uint. Okay, we are having a data type uint, so I am going to convert my data into a float. Okay, so that's why now I'm using same xtrain underscore normalize and then xtest data underscore normalize. I'm calling a xtrain data and then divided by 255. So why 255? Definitely you will know, divided by 255. Okay. So after this, I am printing my output result. So previously for xtrain first image, we are getting an output result like this. Now I am printing same image here, same normalized image. We are getting an output result like this. So that is the use of normalization. Okay. So now you will be comes to know why we are doing like this. After this, we are going to move on the next part. The next part is building our CNN architecture. Build our CNN architecture. Okay. So I am going to save my model first of all. sequential model we imported, right, in separate variable model. So using this model only we are going to create. So according to our PPT, what is the first model? Convolution model plus Relu activation function. I am going to build the first model. Model dot add convolution layer. I am going to use here convolution 2D layer, and I am going to apply the pixel value 32. Okay, filter size is 32. Then kernel size is, I'm going to take 5 comma 5. Okay, so 5 comma 5. If you need means you can use 3 comma 3 also. That is our wish only. 3 comma 3 matrix or 5 comma 5 matrix or 7 comma 7 matrix. Okay, so based on the image size you can take. Here I am just taking randomly 5 comma 5. After this I am using an activation function. Activation function, yeah, as I said before, I'm using Relu activation function. The next one, input size. So what is the input size exactly? We use using shape keyword. We checked the input shape. Yes. Once we scroll down, scroll up, then we'll be get an input shape. Input shape 32 into 32, and then 3 layers, right? So exactly what is your image? All the image input shape you need to give here. So here I am importing the 32 comma 32 3 layers. So this is my first neural network model. Okay, the neural network model which I displayed in our PPT is created. The next one I need to create pooling layer. Okay, so this is the first model. Then sorry, it's not a model, it's a layer. First layer, then second layer. Second layer, same model dot add. Here I need to use a maximum pooling. So I'm using maximum pooling 2D. Then after this, within this maximum pooling 2D, I need to give a pooling size. Okay, how much I need to take each and every pixel value, like 2 comma 2 pixel or 3 comma 3 pixel, like that. Okay, so if I apply 2 comma 2 means I will be get like just wait a minute. Here you can see it will be take 2 comma 2 matrix first, like this. Okay, so that's why we are here, we are using 2 comma 2 maximum pooling. So now we created, according to our PPT, we created one convolution layer and one pooling layer. Next I need to use same convolution and pooling, right? So we already done this one. Just to copy this 2 line and then paste it on the next one. Okay, so here we are now we are working for next convolution layer and pooling layer. Okay, so like this and all, okay, same thing only, but we don't need to give input shape. Why? Because previously we on first layer we given input shapes and all, so erase it. Next one, this one only. Okay, convolution 2D and maximum pooling, same thing. So convolution and pooling. Next one, we need to flatten our output data. So here I need to apply the flattened data. So I'm using model dot add the flatten layer. Okay, so just adding the flatten function is enough. We don't need to give any type of parameters within that one. Just adding the flatten layer is enough. Okay. The next one, after applying the flatten layer, we need to move on to the dense layer. So dense layer is one of the most important to predict and output layers. So this and all we just extracted our futures in the image. See here, future extraction. Okay, we extracted the futures in our images, input image. That is the use of this convolution layer and pooling layer. Next, after extracting the future, we need to predict an output result. For that, we need to apply the dense layer. Okay. So here I am going to build my model dot add dense layer, and I'm applying 250 approximately. Okay, for example, I'm taking here, yeah, here we are applying 32 into 32 megapixel, right? Better we can take 1000. Okay, so 1000 neurons layers I am creating here. After flattening my value, then I am passing within the 1000 neurons all the layers. Then activation function say Relu. Okay. Then after this, I'm going to apply the model dot add. I'm going to apply the dropout layer. Okay, within this 1000 neurons, I need to drop some 50% of neurons. Okay, I need to drop some 50% of neurons. 0.5 means nothing but 50%. So in 1000, 50% means 500, right? Then next layer should be a 500. Model dot add dense layer. Then I'm using 500 units of neurons. Then activation function Relu. Okay. Then again I am using a dropout function model dot add using a dropout function. Then I am reducing into again 0.5. So again 0.5 in 500 means 250, right? So I'm going to create a 250 neurons using dense layer. Dense, then 250 activation function Relu. Okay, so this is enough. Within 250, we need to predict and 10 classmates. It's okay. It's nice only. So I am up to 250. I just done my neurons. The next one is final neuron. That is output layer. So for output layer, previously we used only one output neuron, right? For even RNN also, yesterday's RNN also, or day before yesterday, what is that? Artificial neural network also. Why? Because we need to predict whether it's a negative review or positive review, right? Whether it's a person attacked by diabetes or not. But in today's scenario, we are having 10 classification file. Okay, in today's scenario, we are having a 10 classification data. So 10 means we need to create a 10 neurons as an output layer. Using dense layer, I am going to create a 10 output neurons, 10 units. Okay, after this 10 units, I'm going to use here activation function. Previous class I told you, if it is a binary type of classification, we have to use sigmoid activation function. If it is a multiple type of classification, you have to use softmax. Okay, softmax activation function. So when I apply this softmax activation function, we need to use we need to use loss function, not a loss function. Yes, exactly, loss function. We need to use what type of loss function? Here we converted our loss function is That is, our predicted output will be in the form of this one, right? Binary class matrix only. Okay, so whenever I am using binary class type of matrix value, I need to use a categorical cross entropy as a loss function. Okay, so that one I will tell you. Now if you are check your model dot summary, you will be get a result how it's created. Okay, is it? Yeah, till now I didn't run this. Yes, I am getting an error. Positional. Okay, I'm getting here error. Convolution 2D. Okay, 5 comma 5 activation function relu. Then input shape is 32. It's correct only. Then why I are getting an relu activation function input shape? Just wait a minute. Model dot add. Then convolution 2D 32. 5 comma 5 activation function is equal to relu. Everything is fine. When okay, just wait a minute. Again, same error. Positional argument follows keyword arguments. Yes, input shape equal to. Okay, so now I'm not getting error. Model dot summary. Here, the way of architecture, convolution 2D, maximum pooling 2D, then convolution 2D 1, then maximum 2D 1, then flatten layer, dense layer, dropout, dense, dropout. Sorry, dense. Okay, so this is the way we created our model. Okay, now I'm going to train our model. Okay, so sorry, before training, we need to compile our model, right? That is back propagation, right? We need to do the back propagation compile. So here I'm going to use model dot compile, and then I'm going to use loss. So loss, which loss I have to give here? Anybody have any idea? Previously I even said also what is the loss we need to give. So we need to give the loss of categorical cross entropy. So if I use this, we need to use categorical cross entropy. So here it's already mentioned. So we need to apply this categorical cross entropy. So I'm applying the categorical cross entropy. Then optimizers, same at the starting also we are using Adam optimizer, and then we have metrics. Okay, so metrics is used to find the accuracy. Okay, after this I'm going to compile the model, then create a new line, then train your model. Okay, model.fit using fit function. I am going to train x train, then y train. Sorry, here we need to use y train. Sorry, x train also we made a mistake. Instead of x train, we need to give x train normalization, and y train 1 card key encode. Okay, then I'm going to give the batch size. Previously here also mentioned the batch size, right? Test the batches mentioned. So here I'm giving a random batch size like 256. Then approaches I'm giving here 50. Sorry, it's a image type of data set. So I'm just using here 5. Why? Because it takes too much time to train the algorithm. 15,000 images are there. Okay, so I'm just giving a 5. For 5 iteration, it takes too much time. If you are free means you can work on with 15 times or 20 times. Then you can get an accuracy result more better. Okay. Then here I'm going to give the validation split also. Okay. Validation split means in 15,000 image, okay, 80% of image will be trained the model, then balance 20% of image will be act as a test data. Okay, so that is the use of validation split. Okay, so now I done with this one. Then next one I am going to train the model. Okay, so 5 times I given a hypothesis, then it will take 5 times. Some, yes, here you can see now my model is training, but it takes some time to train the model. I have one idea. Okay, I have an idea. So it will be trained. Okay, we will don't need to bother about this. In between, we will download some random image in Google, like dog image, and then we will test the image whether it's predicting correctly or not. Okay, some dog image I am taking here. For example, yeah, see, I will take this image. We will check it how our model is predicting. Okay, here I'm saving the image. I'm renaming the image as ABC. Okay, otherwise dog. Okay, now I'm going to import the image. You guys will know already how to import the image. So dog image, open. Yeah, it's imported. Now I'm going to read the image, and after training the 5 iteration, I'm going to show you how it's give the prediction result. Okay, so first of all, I need to read the image. So dog plt dot using imread. So to display the image, you need to use im show in matplotlib. To read the image, you have to use im read. Here you will be not get a suggestion. Why? Because here it's running. So I will better I can type the code. im read then dog.jpg. I'm reading the image. After reading the image, I'm save it in one variable dog. Then after save it in one variable dog, for your understanding purpose, I am going to display the image. Okay, so plt dot. Still now I didn't read the cell. Why? Because here it's running. So I just type the code in between. I am show and then dog. Okay, so after saving the dog, I'm using I'm show function and displaying the dog. Okay, then after this, definitely my dog image will be not in the 32 into 32 megapixel, but we trained our model into 32 into 32 megapixel only, right? So we need to convert our this image into 32 into 32 megapixel. So that's why I'm using here one of the newest library package. Till now we didn't see about this. The library package name is SK image. Okay, did you hear the word SK learn for machine learning purpose? But here we are using SK image. Okay, using SK image, I'm going to import the package name is called as a transform. So we need to transform our image into an 32 into 32 megapixel. That is what I'm using here. Then after transforming the image, after importing the transform package, I'm going to resize the image. So I'm saving it in resize variable name using transform package. I am resizing the image into this dog image into 32 into 32 megapixel, right? 32 comma 32. It's a color image, so we have to give 3 layers. So still it's running. I think it's final approach. So for final approach, I'm getting an accuracy result on loss. Loss I'm getting 1.9. Accuracy I'm getting too low for first iteration. But for for fourth iteration, I'm getting same 1.1 and accuracy I'm getting 0.58. It's not a good one. It's not a nice accuracy result. We need to improve the accuracy result, means we need to improve the approach size, but here we don't have time. So just I am iterating our data into 5 times only. Okay, so it may be predict an output, it's a dog, may not be predict, it's not with my hand. So if you need correct output, means you have to improve your approach iteration. Okay, so just I'm getting 62% accuracy result, but we will check it out. Okay, it's not a problem. You need to learn how to give a input data. Here I am getting matplotlib piper dot. I am so SHOW. See here, it's a dark image. So its pixel value is more than 25 megapixel, sorry, 25, 2500 into 3500 megapixel. So I need to convert this 2500 and 35,000 into and 32 into 32. So that's why I'm using this transform library package. Using this transform library package, I'm resizing my image. Transform is not defined. transform. Transforming the image. Then now I will show you the transformed image using IMSO function. It's still loading. Resize. See guys, so this is our image. After I having this image, after this image I am converted into like this. This is a transformed image. Now without giving our test data, I will give this only one input data and I will check it out how it's working, my model. Okay, so now what I have to do means this resized image is there, right? Resized variable is there. I'm going to give this variable to my model. Okay, so predict equal to model dot predict then I'm passing my out input image np dot array value and I'm resizing my array, resize image. After I am resizing, I save it in the variable name resize. Then I am passing my input image to this my trained model. Then I am getting an output result. That is 10 output predicted value. Each and every neurons will be give some result. Within that neurons, which one is giving a higher amount of value? That is our output. So here I am not getting any error. So I'm going to print the neurons predict. See here, this is the 10 output neurons I am getting. Okay, within this 10 output, I am getting which one is maximum? 6.4, 1.4, 9.0. Okay, here I am getting one maximum. And apart from this 2.4, 3.1. Yeah, this is my highest value, 9.0 something. So 0, 1 and 2. So what is the two value? 0, 1 and 2. So it's predicting as a bird. Okay, our model is predicting as a bird, but exactly 0, 1, 2, 3, 4, 5. Fifth neuron is my dog. 0, 1, 2, 3, 4, 5. We are getting too much low. So why we are getting like this means you guys will be know we need to improve the approach result. Here I'm just taking a 5, but I will show you. Just wait a minute. Here you can see this is my Jupyter notebook one. Same thing what we done for you, I previously done. Here I run my model 15 times. Okay, 15 time approach. Then after running the model, I read the image and then this is my doc image. Then I transform my image. Then here you can see I get an output result as a dog. Top 5 is dog, cat, bird or horse. So I'm getting output exactly. Why I'm getting exactly means this is the problem in our today's class. Okay, I just run the 5 times. So if you have means you can check it out. Okay, so and I hope this workshop will be definitely understand helpful for you for your future purpose and then for your improvement, knowledge improvement also. So that's it. I want to tell you about today's session. So if you need this code, I will forward you within this end of this session. Forward as a link to you in our chat box. Okay, so you can download it after this. Before end of this session I will forward the link in our Zoom chat box. You can check it out. Okay, so thank you for this wonderful workshop conducted by the college 10 Joseph, and thank you for the faculty members who arrange this with Pantech e-learning, and thank you for the students who cooperating with us. Thank you all.
Thank you, sir, for a fascinating and fruitful session. Now let's move on to question and answer session.
Yes, ma'am.
The first question, sir. What is the biggest advantage of utilizing CNN?
What is the biggest advantage? Yeah, main thing is it will if you it's used for mainly image type of data set, and it will be predict the image futures accurately when we compare to any other algorithm. So that is the biggest advantage of CNN.
Okay, sir. The last question. How to perform convolution neural network and deep learning algorithm in remote sensing?
Remote sensing. Yes.
Yes,
So
sir.
if you need to perform based on the remote sensing means, first of all, you need to transform your model. Okay. Transforming your model is nothing but here you can see I trained the model, right? After training the model, my model in this variable only, my whole model will be learned how the images will be there, what type of images we need to predict as a this output, like that whole thing will be available in this model only. So you have to save your model. The saving of your model will be called as a transform learning. Okay, so transform learning is nothing but you have to save your model as, if it is a general purpose means you can save your model as a .h5 file. If it is a Android application means you have to save your model as a TF Lite. Okay, so like this we will be have some different type of models. Okay, so you have to save, transform your model into one file, then you can use whenever you need. So that is the use of transform learning. So you have to just Google it, what is transform learning in deep learning, then you will be comes to know about this.
Okay, sir. Thank you, sir. Now
Thank
it's
you.
time to express our gratitude. On behalf of Electronic your busy schedule and joining us to share your knowledge. My heartfelt thanks to our beloved chairman, sir, Dr. B. Babu Manoharan, for to organize a wonderful webinar to gain knowledge. My sincere thanks to our managing directors, Mrs. Jessie Priya ma'am and Mr. Shakti Sekars for their guidance in conducting this webinar. And I would like to express my gratitude to our principal sir, Dr. P. Ravindran, for his support to conduct this webinar, and to our department heads, Dr. C. Nyanakausalya ma'am and Dr. G. Rohit, for their work encouragement to our department staffs and organizing team for arranging this webinar successfully. And finally, my sincere thanks to all the participants for your active participation and support. Thank you all.